Welcome to the first part in a three-part series that is going to cover the rotating puzzles you see in Resident Evil 7. So this is going to include the actual light that projects the shadow, the item, moving the item either with keyboard or with mouse, as well as a simple door opening once the puzzle is solved. So in this first part, we're going to cover an interaction system. And unlike just picking up the item or just showing a simple icon where we're going to pick up, we're going to do it kind of in two parts. The first part is going to be if you are close to an item that you can interact with, a little dot will appear where that item is located in the world. And if you get close enough to pick it up, then there will be a second icon that will appear above, which will be the input you press to pick that item up. So that's what we're going to be covering today. We're doing this in Unreal Engine 5.7 this time, so make sure you're using the same version if you want to avoid any issues. Most of the stuff probably works in some older versions as well, but it's always better to be on the same version as me. Then you will have the least bugs if you follow along correctly. Let's begin. Now, 5.7 looks a bit different, so we're starting off here this time. We're going to go to New Project right here, and we're going to go with our typical games. And the templates have changed a bit, so we're going to go with the first person, and we're going to choose target platform desktop. We're going to leave the quality preset at maximum. It doesn't really matter, it doesn't change anything, and you can change it later. And for the variant, we're going to use survival. Now, this works perfectly fine without it. It's just that we're going to go in the mood and just go with the survival horror. We'll call this re_puzzle mechanic. And then we will just create the project. So, a few things I want to share about the project, about the current situation is, first, I'm going to be focusing on more smaller projects for a bit, so this three-part series and other ones about the same size. I want to avoid long projects like I was doing before. The reason I've been a bit slow on the uploads is because I've been very busy working on my own project. And so instead of asking you to subscribe, I'd like to ask you instead, if you or somebody you know enjoys Call of Duty Zombies, then in the description, the first link there is a link to the website of the game I am working on. We still haven't shared anything visually on it, and we're still making progress behind the scenes. But if it sounds like something you or somebody you know would enjoy, then we'd really appreciate it if you were there once we start sharing information about it. One other thing I'd like to share before we get into the project itself is I also plan on making this same project in C++. So I would like to know if that's something anybody would be interested in, because what's likely going to happen is I will be uploading these three parts in one go, working on the C++ project, and then doing the same thing, uploading three parts there as well. And I'm going to try to keep the C++ and the blueprints as close to each other as possible, so the two videos kind of can be interchanged. Not so that you can mix them together, because that won't work, but more in the sense that way you can kind of see how they translate, because although it is C++, it is special C++ just for Unreal, so it is very different from your typical C++, and if you're familiar with blueprints, it's actually pretty easy to cross over. And as I've been working on my game recently, I've learned how useful it is to know C++ over blueprints, because you never have to wonder if you can do something, because the answer is always yes. You just need to figure out how, and there are no limitations that you might encounter that you have with blueprints. So with that out of the way, let's get into it. So, first thing we're going to do before we do any blueprints at all, let's just import everything we're going to need for the whole project. Now, one thing you will not have in the project files that is in the showcase is the sound effects from Resident Evil, obviously, because I cannot share those. We're instead just going to use Unreal Engine sounds, which are already in the project, but either way, it's not too important. It's just a play sound node. In the description, you'll be able to find a link to the Google Drive with the assets in there. So I'm going to pull them from my second screen and drag them in right now. Now, here we go. Let's create a new folder, which we'll call Puzzle. Inside it, we will have a new folder for assets. And in the assets, we're just going to drag all of this in. There we go. So most of these settings, or all of these settings, we can leave by default and just say import, and it'll get them all here. Control-Shift-S to save them all. And we're mostly going to be focusing on these pieces here. That's the ones that we're going to be using today. So let's get into it. Let's start by creating everything we're going to need. So in our puzzle, we're going to create a new folder for blueprints, and we're going to need a few things. First, we're going to create a new blueprint class right here, and we're going to call it, what we're looking for is we are looking for the first person character essentially, and we're just going to make a child of it. So we're going to do that by looking in all classes for first person, and we're going to look for character here. Now, we're going to select this instead, delete this, and we actually have a sub or already a child of the first person character, which is called the horror character. And so pretty much all this one has in addition to the normal one is, I'm pretty sure, a stamina bar. But we can use this, so we're going to keep this here. We're going to select this, and we're going to say BP underscore, we'll just say character. That's enough for now. And so right now, if we play, we're not actually going to be using our character right now. And the reason for that is because the project doesn't know that we want to use that. So to change that, we're going to go to world settings. We're going to see game mode override. Right here is our first person game mode, but we want to change that to our new one. So we don't have a game mode. We don't need a game mode. We're just changing the character. So we want to click this drop down and change the default pawn class. So right now it is BP first person character. Click on it, and we're going to select, instead of our horror here or our first person, we're going to select our BP character. And if we play, well, it's changed, but we have no way of seeing that. So we're just going to do a little print on our character right here. So event graph, and let's just say on begin play, no, print string. There we go. So we're just going to print hello. Once we spawn, it should say it. There we go. In the top left, we have our hello. It's working just fine. And we can move. As you can see, characters walking just fine. Now, there is a little issue I just remembered. The reason this looks a bit different is because, the reason there's no stamina bar is because we don't have the stamina bar set up, because that is in the horror game mode. So instead of the override, we're actually going to change it to our horror game mode here. And so that will have replaced everything here. This is kind of the two that we need. So we're going to leave this. We're just going to change this back to our character. And now if we play, we have our stamina bar at the bottom. And if we press shift and sprint, it goes down. And now if we let go, it recharges. There we go. That does it for our character. It's made now. So we can delete this. It did print. Yeah, it did print. So we'll close this for now. We'll get to it in a second. Next, we are going to need another blueprint class here. And what we're going to look for is our horror. That's not how you write horror. Horror, and what we're looking for is our BP PC controller. So this is the player controller. So select this, we'll say BP underscore controller. Now, we're going to replace our BP horror player controller here as well with the new one we just made. So BP controller. So if we play, nothing should have changed. It should still work. We should still be able to run just fine, but the stamina isn't draining. So let's figure out why that is. So I apologize, I used the wrong controller. So it shouldn't be this one. For some reason there's a second one, I'm not sure why there's two. So go ahead and open your BP controller, and we're going to change this one because that's not correct. What we're looking for instead is in our class settings to change it. We are looking for BP underscore horror, and what we're looking for is horror player controller. So reparent, and that should fix the issue. Let's play and see if that worked. Yep, so now if we sprint, it's correct, and we still, as you can see, have our BP controller right here. So I have no clue why there's two of those, but the one we're using is the BP horror player controller. And so we can remove that. This is the one we'll be working with. So close it for now. We'll finish the last things we need. Go. Yeah, so the next one we need is, we're going to need a UMG. So back in our puzzle, first we'll make the blueprint interface. So look in our, right click, go down to blueprint, look for blueprint interface, and we're going to call this BPI underscore interaction. one more left. Sorry, I completely forgot. We need something to interact with. So we're going to make an actor. And we'll call this A or puzzle piece. And this is going to be the thing that we pick up to actually interact. Or this is the puzzle piece. And so finally, we need one last thing, which is just the widget, which allows us to display the information. So we're not going to put that in Blueprint. We're going to put that in UI. So user interface, and open that up, right click, and we're going to go down to user interface and widget blueprint. So user widget is fine. And this will be umg_interact. Now that's everything we need. Let's start with the interaction blueprint interface, because that is the basis of everything, and it's very easy to set up because it doesn't need any other references other than the actors. So double click to open that up, and you should be greeted by this. So we're going to need 6 or so functions. So we're going to name them all. First one is begin overlap. As the name suggests, it's when you overlap with something that can be interacted with. This one gets called. Then end overlap. The opposite. Interact, which is when we actually press the button to interact. And finally, we have another function. This is more an assisting function of sorts. It's going to be called interact location. And what this one is for is, in the event, let's say we want to display the icon on the object. If we use just the direct location of the actor, that works, but sometimes the pivot isn't exactly where you would want the icon to appear. So we use this function so that we can adjust it on a case-by-case basis if we would like that. And finally, the last one, which is going to be can or ignore interaction. So in the event that the puzzle is solved, this becomes true and we can't interact with it anymore. So this one needs to return a boolean, so we'll say return value. The interact location needs to return a location, so that's going to be a vector. Once again, return value will do. For interact, we're going to have 2 things. We're going to need an input, which is the interactor, so in most cases the player, and this is going to be of type actor, like this. And then we want to know if it was successful on the return. So successful, and it is a boolean. For end overlap and begin overlap, we just want to know the actor that is overlapping. So look for actor and overlapped actor. I will just copy this and we'll put it at the end overlap as well. So we can compile save and we can close this. Now let's start with the puzzle piece, because that's also going to be extremely easy to set up. So open the puzzle piece, and for the puzzle piece we'll start by adding a static mesh, which is going to be our appearance. So place a static mesh right there instead of the scene root. We don't really need it. And we're going to set it to our actor, which is the puzzle, I believe, puzzle piece. So that's what its appearance will look like. Nothing too fancy. And finally, we're going to add on top of this, we want something to like detect the collision. So we're looking for a sphere collision. Now, we want the sphere collision to be rather big so that we have, this is not to detect whether the player can pick it up, but to detect when the player can see it, so to speak. So we're going to say 500 as far as the radius goes. So it should be rather big, like this. So if we look in the scene, so if we just place it so we have an idea, it's not that large. Like you can more than spot it from a distance, but once you get around here, it will show you that you can actually interact with this item. It won't tell you what button, or it won't let you interact, but you will know that you can actually interact with it. As far as logic goes in here, we barely need anything. We're just going to add our blueprint interface. So we're going to go to class settings, I believe. Yes, class settings. And in the implemented interface, we're looking for our BPI and interaction. So that will make the interface tab here appear. And if we pull this down, we'll have all this information. Now, we don't need to do anything for ignore. We don't need to do anything for interact. Well, actually, we do need to do something for interact location, sorry. We want it to by default just be get actor location for this. Now, if in your case, you're not using the same static mesh, maybe you want to adjust this. In that case, you can just say plus whatever it is, because this is in world space, so you still need the actor location. For interact, we only want this item to be interactable by the player. So in that case, we're just going to say cast to FPS, or sorry, cast to character. That's what we called it. So BP character. Make sure you choose the BP one, not basic character. And we're just going to say, if it's found, destroy this actor. And we'll say it was successful, true. Otherwise, if it's not the character interacting, we don't do anything and we say it failed. And for end and begin overlap, we do nothing because that will be handled via the actual project, via the character itself, and we don't need it to do anything here. Because if you overlap, we're not going to change anything. That's going to happen in the UI. So the puzzle piece is done. I forgot something. We need to actually add controllers or inputs for the player. So to do that, we need to make a new folder for that. So we have our inputs right here. And for the inputs, we're going to make all of them in one go. That way we don't have to go back and forth later. So we're going to need an input action. So that is in our input action. And we're going to call this IA_cancel. And we're just going to duplicate this. And this one's going to be confirm. Duplicate it again. This one is going to be grab. Duplicate it again. This one will be interact, which is what we're doing today. And finally, this one will be rotate. Now, what we're going to do now is we're going to make our input mapping context. And so these are the things that we're actually going to swap to say, if we're the player, we only have interact. But if we're on the puzzle piece, then you can use all the other ones. And so to that, we'll just make a input again, input mapping context, IMC_player. Just leave that player and double click to open this. And we just want to have our interact key. So mapping plus and search for interact right here. And we'll just choose F as a key. So close this. And we're not going to do the second one. We'll do the second one once we actually need it, which will be in the next part. If we close this now, go back to our puzzle, our blueprint. Now we need to modify the controller, because the controller is where we're going to grant this input mapping context. So double click on that and let's get into it. So begin play, we want to do nothing. And the reason we're not doing anything on begin play like you would usually expect, usually it's I begin play, I add the UI for the interact, and we'll show the icon as we get closer. We're not going to do that here. And the reason we're not going to do that here is because as we navigate through the project, when we get to our point of solving the puzzle, to do that, we're going to actually unpossess our character. And so if we unpossess our character and we do our UI in begin play, it's not great, because we might want to make it reappear here, not in tick, sorry, but we might want to make it reappear and disappear when we change characters. So instead of using begin play, and we don't need EventTick, we're going to use EventOnPossessed. So this one right here. Now make sure when you use this that you right click and add call to parent, because in the parent controller right here, there is some logic on the onPossess. So we need to call the parent once that it does this logic. So like this and like this. Now what we're going to do, as I mentioned, we only want to do it on the character. So we're going to say cast to character. And this time I want to be very specific. We are talking about this character. We are not talking about our BP character, specifically this character. And the reason we're doing this one is because we know that our BP character somewhere down the line inherits from this class, which is the character class. We don't need that information. We just want to know that we're using our player character. So we want to know which pawn is getting possessed. So we'll just do this. And now we know. So we don't need this. We pretty much just want to check this. So then what we want to do is we are going to get our enhanced input local player subsystem. So this is just so we can add our input mapping. So what we're going to do is add mapping context. And right here, plug this in. And right here, we're going to add our IMC underscore, and we're looking for player. Now with this, technically nothing will happen for now, but if we go into our, let's say, player character, we add our IA underscore interact, which is the one that is being granted. If we put a print string here and we play, normally if we press F, we should be getting hello. Now, if we go and remove this and we play again, if we press F, nothing happens because we don't have the mapping context. We don't have the keybind being connected. So we'll just leave this here for now, or we'll get into that in a second. Now, the next thing we need is we need the UI. So for the UI, we're going to make a variable so that we know we have it. So we're going to call this interact UI. And we're going to look for our UMG interact right here. So with this, we're going to say is valid. If it is valid, we want to make sure it is set to be not hit testable. And so the reason is because if this is not valid, that means we need to create it. That means it doesn't exist yet. But if it does exist and we've just hidden it, we want to make sure it becomes visible. So to do that, we're going to copy this and we're going to say set visibility to be hidden. So not hidden, sorry. Not hit testable, self and all children. Now, on the other hand, as I said, here we're going to say create widget, and we're going to select our UI, not horror, our UMG interact. We're going to save this here. So drag and alt, sorry. I didn't explain that, but pretty much from here, if you hold control, you get a get. If you hold alt, you get a set. So it's just a quick shortcut that avoids having to drop it and then select which one. So now we're going to say add to player screen, and not this one. This one will just recreate a getter for no reason. We already have it, so we just do this one, and this works just fine. Now, there's one other thing we do need to do here, because even if we do this, let's assume we walked up here and we interacted, and we had the UI visible. If we interact, it should be removed, right? But the issue is we also want to make sure that we remove this. And so to do that, well, we need to have a reference to it. And that's why we're doing this in the controller, because in the controller, we have our horror UI as well here. And so that allows us to actually hide this. So just so you know, if you're wondering what you do have, even though it's not visible here, you can always go to the gear here, click show inherited variables, and it's going to show you a lot of extra stuff. And so this is all stuff that is in the C++ headers and all parent classes. So there's a lot of stuff. And most of the time you won't need it all. But in our case, we know that the parent does have a horror UI here. And so we want to make sure that that is hidden as well. Now to just check that this is working, even though we're not going to possess the thing, we're going to plug this in at the end here. And we're going to say to hide it instead. So if we now compile and play, we won't have any UI. So as you can see, it's hidden. But if we run, we can still run out of stamina. And the system is still there. So it's just hidden now. And that's what we're going to do whenever we possess something that isn't the player. So we'll say not testable. Now, this does it for displaying when we start using the player. But now we need to do the opposite. So now we're going to say event on OnPossessed. So same thing. And once again, we want to get the parent just in case. And I'm also just going to hide these. There we go. So right click, add call to parent, plug it in here. Now we're going to do a sequence. Plug this in here. And this is just to keep things tidy. What we're going to do is... Oh wait, sorry. I completely forgot something. In here, we also want to make sure we remove the basic mapping. So copy this, control drag to plug this in here instead, grab this and plug it in here, and we're going to add the default. And the reason we're doing this is because when we possess something that isn't the player, so when this possession loses, so on unpossessed here, we're going to make sure that the player can't move anymore, because otherwise, the player would still be able to walk around by pressing WASD, even though they shouldn't be able to. So That's why we need to re-add our defaults, which is going to contain our movement, our camera, etc. But we're going to set up our own when we go into here. So right here, we're going to get interact UI, and we're going to say is valid, like this. And we're pretty much just going to copy this, but instead we're going to say hidden. So on true, this becomes hidden. There we go. And on the other hand, we're going to once again get our enhanced input local player subsystem, and we're going to say remove mapping context. And to plug this in, the mapping context we're going to remove is our layer, and we're also going to copy this and remove our default one as well. So get default, plug this in here, and that will do it for our controller. So just to recap again, when we possess a character, so most of the time, we're going to make sure we give it the player inputs, so our interact, but also our walking and our camera movement with this. Then, if our interact UI exists, we're going to make sure it becomes visible as well as the horror UI. Then we're going to go and, sorry, if it doesn't exist, we're going to create the UMG interact. Now, normally this is just called on begin play essentially, and this handles the rest. But so we don't need to add the horror becomes visible here because that's done in the parent one, so we don't need to worry about that. Now on unpossessed, so when the pawn is lost, so to speak, if the UI is visible, is valid, sorry, then we want to hide it. And once we're done with that, we're going to say that we lose our ability to move and our ability to interact, at least via this method, right? So we can now compile this and close. We are done here. We're going to do our player now. So the first thing we're going to do is we're going to handle our overlapping. That way that is out of the way and we know exactly what's going on. So we're going to go on components begin, select our capsule component, and we're going to go all the way down here on the right, and we're going to look for on begin overlap, and we're going to do the same thing for end overlap. So both of these. Drag them a bit down, we need a bit of space, and here we go. So first thing we need is we need to check if we can interact with the item. So we're going to say does object implement interface. BPI, once again, interaction, drag this here, copy this, and we're going to put it on actor as well. Put a branch right here. We'll do another one here. And all we're going to do is we're just going to print this. So we're going to say print string, hello, copy it, place it here, and we're going to say goodbye. Compile, save, and we'll play it and see if when we get close to that, it will interact. So it should be around here. We get hello, move away, we get goodbye. So working as intended. Now, if this happens, very simple. On begin, we're simply going to say begin overlap. And we want to make sure we choose the message. The target is going to be this actor here. So we're going to add a reroute here. Plug this into the target. And for the overlapped actor, it is self. It is the player that overlapped. And what we're going to do here is we're going to grab this and we're going to say promote to a variable. And this is going to be our overlapped targets. And we're going to change this into an array. And we are going to add this array. So add right here, plug this in, and there we go. Now, on the other hand, on the bottom, we're going to do another reroute as well. Press R, I forgot to mention, R to add a reroute. And we're going to look for end overlap message. And for, once again, our overlap actor, it is self. And instead of add, remove. So just say remove, get a reference to our overlap targets, control, and remove item. Place this here. For the next bit, because there's a bit more after here, we're going to need a few extra variables. First, we're going to need a float, which is going to be called our interaction range. It is going to be a float and it's going to be a null variable. So right click to convert the array into a single parameter. Then we're going to duplicate, and we're going to need the closest interactor. And so this is going to be an actor. So search for actor, go. And we can leave the last variable. These are all we need for now. And sorry, they're fine for the variables, but now we need an extra little thing, which is called an event dispatcher. So we're going to look for new overlapping actor. Oh, sorry, let me rename that. New closest overlapping actor. And then we're going to have another one, which is going to be called stop overlapping all actors. And so pretty much we're going to call this if the current closest actor that we can interact with has changed. And this is going to be called when there are no objects that we can interact with. And so with these two, pretty much we can handle almost any situation as far as interaction goes. So to finish this, what we need to know is we need to know if this, the thing that we stopped overlapping with, is equal to our closest interactor. Because if it is, that means that the closest interactor has changed, so we need to delete it, so to speak. So to delete it, we're going to say it is empty by dragging in an empty set variable here. Now we're going to add a reroute around here just so it's a bit more readable. And here we're going to add another branch. And so in this branch, what we're going to do, oh sorry, I completely forgot something. Right here, this needs to have a input, and this input is going to be an actor. And we're going to call this overlapped. And it's the same thing for the stop all, it's going to be an overlapped as well. It's going to be an actor as well called overlapped, sorry. And so what we're going to check here is if overlap targets is empty. Because if it is empty, that means we need to let the system know that it needs to stop all actors. So drag this in here and say cool. And the overlap actor that just stopped is this one right here. So we can drag this all the way down right to here. So what this does, if something overlaps and it is an interactable actor, then the branch will let us know, we begin overlap, and we make the system know that the targets have a new element to it. If we stop overlapping, is it an interactable item? Then we care. So if it's true, we end overlap. We remove it from our array, and we check if it was the closest one. If it is the closest one, then we set that closest interactor to be empty. And then we want to check if there are still things to overlap with. If there aren't, or to interact with, sorry. If there aren't, then we call stop overlapping all actors because there's nothing left to interact with. So by itself, this pretty much doesn't do anything, because what we're going to need now is we're going to need the tick to handle this. So in here, we're going to say if our branch is empty, our overlapped actors are empty, so is not empty here we can use. If it's not empty, then we do the following logic. Otherwise, we do nothing. So what we're going to do is we're going to create a reroute node right here. We're going to right click on it, and we're going to say collapse the function. And this will be called determine closest item. We'll call it item. So right here, and it needs an output of type actor. This is output pin, we'll call it. Now what this is going to do, we're going to reroute here a few times actually. First, we're going to check if it's valid. Now in most cases, it should be valid, but we still want to make sure that we don't use something that doesn't exist. What we're going to do here is we're going to get our closest actor, and we're going to say right click, convert to validated. If it is currently valid, but the next one, our closest item now, is invalid, then we want to make sure that our closest becomes invalid, and we're going to say stop calling all actors because something went wrong. So overlapped is nothing because there is nothing interacting. Something went wrong, shouldn't have happened. Now on the other hand, if it is valid, we're going to check if it is different from our currently closest, because if it's the same, then we don't care. It doesn't matter. There's nothing to do. So we're just going to do this here, pause it back. And so if it is different, so we pass on the true, then we can say set closest interactor to the new value, to the new closest one. And then we can call our new closest, call right here, call overlapped. So let's say our new one is our closest interactor right here. So if we want to check if this works, what we can do is we can get our new closest here, and we will say bind right here. Create, not create, we'll say custom events, and we'll say print string right here. This will be new closest right here. And then we're going to get the second one here, stop all, call, not call. Right here, assign, and that will create one for us. And for this one, we'll just say print string, and this is no overlapping. There we go. So right now, these aren't going to work because there's no logic here yet, because this doesn't work. So let's go ahead and make this, and then we will test whether they are overlapping correctly. So normally what we're going to do here is we're just going to do a for each loop through the targets and determine which is the closest one. It's nothing too difficult. But before we do that, we actually want to check some other things first, or in addition to that. First, we're going to check is closer item. This is just to simplify what we're going to do in here. So this is going to be the item. So it's going to be item, we'll call it. And second is going to be the closest distance. So the current closest distance. And it's going to return a boolean of whether it is closest. So return value. And this can be a pure function. Next, we're going to have can see item, which is going to be a very simple function that just kind of does a line trace between the player camera and the item. If you can line straight to it, then that means we can see it and we can apply the interact to it. If it's through a wall, we don't want to see it because that wouldn't make sense. So we have that, and that's also going to be an item. So right here, look for actor, and we're going to say item, and on return, it's going to be a boolean, which is the return value, and it will just return if we can see the item or not. So this can also be pure. And finally, last one was we'll just duplicate this, and it is can interact. And so this one, just like the name suggests, it uses the ignore interaction that we made earlier. And so we're going to look for ignore interaction message, get the target, and we'll just say not boolean, because if we're ignoring it, then we cannot interact. But if we cannot ignore it, then we can interact. So close this. Can see is the next one we'll do here. So can see, first thing we need is our custom location. So we're going to drag from here, from our item, and we're going to say interact location message. Plug this in here. Then we're going to say line trace by channel. And we're going to start at our camera instead. So get first person camera, get world location, and plug this into the start, and plug this into the end. It doesn't really matter which one is which, but I prefer to go from the camera. It's easier. And so what we're going to do is branch. If nothing was hit, we can return true because there was nothing in the way. If we hit something, we need to actually check if we didn't hit the item itself. So we're going to break this, and we're simply going to look if the hit actor is double equal to the item at the top, I believe. Yeah, get item here. And we'll just plug that into return value here. So like this should be the results. There we go. So this is what it should look like. And we'll just leave this on for duration so we can see it once we test. So we can close this, and now we have is closer. So is closer is also going to use a similar thing. So we're going to get our location again. So interact location message. And we're going to check the distance vector from our get actor location. Now you can use the camera location for this as well, but it doesn't matter too much because they're checking on the same location, all of them together. So we're just going to promote this so it's easy to read. And we'll call this L underscore new distance. Plug this in here. There we go. And what we're going to do is we can't just immediately return this. And I just realized we need an extra return value here. So this cannot be pure. And so what we're looking for is our new distance. So float, just copy the return value here. That's not going to work. So this is new distance, and this is the return value instead. So the new distance is going to be new distance here. And for the return value, we're going to need a few things. First is our closest distance. And if our closest distance is double equal to -1, that means that it is starting. So in that case, it is okay. That means this is a new distance we want to use. But we also want to check if our new distance and our closest distance, if our new distance is less than our closest distance, that means that we are closer with our new item. So it is closer, so we return true. So like this is what it should look like at the end. Now we can close this and we can finally go through the whole loop itself. So to do this, we get our overlap targets, we for each loop through them. For each loop, you can just press F, but apparently it doesn't want to with me. Overlap targets, this, and what we're going to do is we're going to have a few local variables. So the first one is going to be our closest, or no, we'll use L closest item. And then we're going to add another one, which is going to be L underscore closest distance. So the second one is obviously going to be a float. Now, so the return or output is going to be our closest item. It's going to be on completed. And now we want to check is closer item. And so our closest distance is going to be our closest distance. And we want to make sure, before I forget, that this starts off by default at -1. So our item is this. So we're just going to add a reroute because there are a lot of times we're going to need this. So I'm just going to drag a few here. Actually, no, we'll do it this way. So reroute here into this. And we're going to need a branch. But we made some extra functions for this because this just checks the distance. We also want to know if we can see it. So we're going to say reroute can see item. Like this, and one last one for can interact. And so if all three of these are okay and they do work, then we can actually use it. So we'll say and add an extra pin, plug these three in like this, and we'll pass it into the condition. And so if this condition is met, then we can get our new distance and we can actually save it to our closest distance, which will then be checked on the next loop and the next loop after that, etc. And we also want to save, obviously, our closest item to be used if it needs. There we go. So that will do it for this. So now, if we run this, we should be able to tell that we get closer to an item if we walk or we overlap now. So let's try that. So if we walk here, as you can see, all of a sudden there are loads of line traces appearing. And they're a bit behind us because they're actually right in front of us, but we can't see them until we move away. So as you can see, it keeps line tracing. If we move away though, it stops line tracing because we're out of range, and it says no overlapping because we are not overlapping with any items anymore. Now right here, same again, new closest, we leave, it stops. But what about if there's a second item? So let's make a second one of these. So Alt drag to make a second, and we'll make it so that they're overlapping, so that two of them, so that you can technically be on both at once. So if we now play, and walk towards this one, our line trace will go here. But if we go over the second one, the line trace is on both, because it obviously detects both and it's going to try and determine which one is closer. Now, let's see if we can figure out what that one is. Now, it's already done. Let's just add a print so that we know. Actually, no, sorry, we don't need to do that. We're just going to be able to tell when it sends our message. So if we go close to this one, it's going to say new closest. But if we walk towards this one becomes a new closest, and back, so on and so forth. Okay, so all that's left now is the UI. So let's get that done, because this is taking a lot longer than I thought it would. So let's get that finished. So for the UI, now the UI isn't too difficult. There's only a few little things we need to add visually, and then there's only a few little things we need to add as far as code is concerned. So the first thing we need is a canvas panel, and we have to use a canvas panel because the code that allows us to place the icon on an object in world space needs to work with a canvas panel, so we can't actually use an overlay or anything like that. Then we're going to add a vertical box, and this is just for the visual part. So we want to make sure this appears at 0.5 here and 1 on the Y, so that it appears above the location in the world space. That way the arrow that we're going to place right here is always on top, not exactly on it, but slightly on top. Now, if you want this to be different, you're free to change that. You can just tweak the alignment here, and that will work just fine. As far as size-wise is concerned, we want it to be 60 by 90. So it should look like this. Then we're going to add an overlay. So inside of here, the overlay is going to be fill, so it fills up the whole thing. And then we're going to add an image right here. We're going to add some text, which is going to be the key. And so we're not going to do anything too complicated here. The key is just going to be F, like this. And so what we're going to look for is our image here needs to be set to horizontally aligned center and vertically aligned to the bottom. And we're going to change the brush to be our input key, like this. And it may look a bit strange, that's fine for now. We're going to get to that in a second. Because the next thing we're going to need is the arrow. So we're going to look for a second image here. Just image, not text image. And we're going to place this one in the vertical box, not the overlay, the vertical box. And this one is going to be called arrow. And I'm not sure why, but I have 2 input arrows. So I think I've used the wrong one here. And we need to actually change the size to 30 by 30, so it appears a bit more normally. And for the image, we're actually going to change that as well, because I believe it is not input key, but input key 2, I'm pretty sure. For our second image, our arrow, we want to make sure it is centered as well. We want to make sure it is aligned to the bottom, and we're going to give it a padding of 10 on top, like this. Now, for the image, we need to make a little change as well. So this is good, sorry. And we also want to change the size to 50 by 50. So now it's a bit better, it looks a bit nicer. And finally, we also want to make sure our F here is centered as well. So click on this. And we also want to make sure it is black so we can actually see it. So drag this to the bottom, there we go. And sorry, we actually want to add a little margin here, so make sure it's centered. Yeah, right here we want to change this. I want to change it from top to be 7, so this makes it a bit more centered as we want it. So this is what it looks like. If we play right now, because the UMG is already added, we don't actually see it because it is in the top left. So just for testing purposes, I'm going to drag this into the box. So just play. There we go. So now you can see it. It is in the top left. It is visible. And now let's make it so that it moves. So you can leave it here. It doesn't really matter because we're going to be changing this as we go. So just actually reset. Sorry, not that one. Reset its position to 0, 0. It's better that way. Go to the graph, and we now need one thing. We need this here, this overlay. Sorry, not the overlay. We need the vertical box to be a variable because we're going to use that to change its position. So we'll call this VB_icon. We need to make an animation. So this animation is very simple. We're going to go into our animation here. We're going to say show keybind. Because by default, sorry, I completely forgot, but our overlay here needs to be hidden. It needs to be 0 on the render opacity. Because by default, when you see an object, this will show up and then this will show up. So in the animation, we're going to do exactly that. So we're going to add our overlay. We're going to look for our track here, and we're going to look for render opacity. It should be 0 by default. Press the plus, normally it should be by default there. And at 20 or so, we will say it needs to be 1. And so now if you play this, it's just a simple fade in, nothing special or anything, just simple fading. And now we can close this. Now we're done. Now we have our animation. It should appear right here. Okay. So what we're going to need here is two things. We're going to need our construct and we're going to need our EventTick. So first we will do the construct. So for this, we'll say get owning player. Get owning player, please. And we're going to say get controlled pawn. I think we can actually use this, sorry, directly. And we're going to cast to our character. So this one this time we need. Because we need to get a reference to the event dispatchers, which are only here. We do though need to save this. So we're going to promote this to a variable, which we will call as BP player character works fine. And we're going to use this to bind event to start to closest, new closest overlap. So like this, we're going to say a custom event. This is going to be called new closest. Doesn't really matter too much. We're just leaving it like this anyway. And we're going to promote this to a variable, which we'll be calling overlapped. Works fine. And if this is true, we're going to say set visibility to be not hit testable, self null chilled. Now we're going to add the second one. We're going to call bind stop overlapping all actors. Same way. Drag this a bit further so we have a bit of space. Custom events, and this time same thing. Stop overlap, we'll call it. Now in this case, we want to do a few things. First, if this is valid, sorry, if it's not valid, so we added a not boolean, sorry, not boolean, or if the overlapped here is double equal to our overlapped that we just had, that means that what we're looking at needs to be removed. So in this case, if for instance we call it from this segment here, it's not valid. So that means it will go here and pass the true. Now on the other hand, if it was the closest overlap and that is stopped because we have left the area like here, then this also works as well. And in that case, we're going to say overlap is empty, like this. And we're going to call set visibility to be hidden, like this. And so normally this should be enough to display. So I'm just going to go and remove this back to here so we can see it, and we'll play. So normally, so this is technically working. It's just that right now it is by default visible because we haven't told it to hide. So if we go and walk towards this, normally you'd be displaying. Now if we leave, it disappears. If we get closer, it reappears and it's gone once again. So that is working as intended. Now, so what we'll do is we'll go into our UMG widget here. We'll move this back to 0. We'll select our UMG interact and we'll say that by default, it is hidden. So now it is not visible until we actually walk into an area with an object we can interact with. Although right now it's gone back to the top left, so it's not visible. So let's go to the graph and let's do our event tick. So we're going to start with the simple bit. So if our overlapped is invalid, so to check that, we can convert to validated here and do this. If this is not valid, so our, what we're going to do, sorry, I completely forgot something. We need to have this be displayed as a variable as well. So we'll call this overlap keybind. We'll call it back into this. If this isn't valid, that means we are no longer overlapping with anything. So what that means is we need to check if our keybind is visible, because if we're not overlapping with anything, it should be invisible. So we're going to check if our overlap keybind gets render opacity. If this render opacity is superior to 0, that means that it is still visible. And if it is still visible, we want to make sure it is no longer visible. So we're going to get our animation, and we're going to say play animation reverse. And so that will make sure that this is hidden every time we leave the area if it hasn't been already. Next is the opposite. So if it is in an overlapping range. So first what we want to check is the player in range to interact? Because if it is, we want to show the keybind. So what we'll do is we will get our player character. We will get our actor location. And sorry, I'm going to put this, I remember, need to set it to a value. So this is in our player character. Make sure we set this to a default, because right now it's 0, so it won't work. So make sure you put it to 250. And so that's just so that's the range we can interact within. So if our player actor here and our distance to our overlapped actor here, so get, we want to use our message here. Interact location. If the distance between these two, right here, it's like this, there we go. If the distance between these two is inferior to our BP character interaction range, then that means we can actually display the keybind, because the player can actually interact with it. So let me just line this up with Q. So if this is the case, we want to actually let the system know that we can interact. So this technically doesn't change as far as the player is concerned. Next, what I'm going to do, actually, before we do any of this, I'm going to do this part first. So what we're going to do here is we're going to get our interact location, plug this into the then part 2, or part 1, sorry. And what we're going to do is we're going to get our VB icon, and we're going to say slot canvas slot, or slot as canvas slot, sorry. And we're going to say set position. So I just remembered, because we're doing this with position, you need to make sure our VB box, our VB icon is in the top left in 0, 0, because what we're going to be doing is we're changing this value. So we're going to use this to move it like this. So go back to our graph, and what we're going to do here is we're going to get player controller, and with it there's a function called project world location to widget position. And so the position we're looking for is this, and the screen position is this. And so normally, if this worked correctly, we compile and save. If we walk towards these areas, they'll display it, and we'll be able to see it line up with the object. So you can see right there, if we move closer to this one, now it's closest, the icon appears there. Even if we turn around, it's not there because that is not close enough, but if we move a bit closer, it moves to this one again. So working as planned. Now the next part is to say, can we show the keybind? So this is a bit more like just extra stuff so that it works smoothly with the icon, with the animation, because otherwise we could just snap it on and off by distance, but we want to make it clean. We want to make it actually fade in and out. So we're doing a little bit more here. So first we want to check, we want another branch here. So I'm going to give us a bit of space to work with. We want to look for show keybind is animation playing. If it is not playing, so not Boolean here, and our overlap get render targets, render opacity, sorry, not render targets, get render opacity is inferior to 1, not 0.1, to 1. What this means is that it is not currently moving. That means it is either at 0, most likely, and not visible. So in that case, if it is not playing and it is not at 1, we want to play the animation. So we're going to say if these conditions are met, we pretty much want to play the animation. Now, if this animation is already playing potentially, or freezed or stopped for some reason, we want to make sure we say our get animation current time, and we want to call this and apply it to a play animation so that it keeps going from the same point so it doesn't glitch out. Now, normally this doesn't work, and the reason it doesn't work is because it is a pure function. So that means this node gets called when it gets attached here. But the issue is that is right here we're going to call from here stop animation stop. Now normally this shouldn't happen because it isn't supposed to be playing. No, sorry, we don't need this. So what we're going to do is we're going to make sure we're playing from the same point that we are currently at. In the event that it has been paused, if the player, for instance, is moving back and forth right at the limit, it could be at 0.5, 0.3 render opacity. In that case, we want to keep the animation going from where it is. So we're going to get our show keybind again. We're going to say play animation, and the start time we want to use is the current time. So just plug this into true like this and leave everything like this just fine. There we go. So this is the first part. So this is if the animation isn't playing and it isn't at 1, play the animation from where it currently is. Now on the other hand, we're going to copy this and we're going to say instead of this, if it is superior to 0. So sorry, I'm just going to make sure this is clear here. The true here is if we are within the range. So we want to show the keybind. If this is false, that means that the keybind is already visible and we don't care, or it is becoming visible. So we don't care, we let it keep going. Now on the other hand, here is if it is not supposed to be visible. Now if it is superior to 0, that means it is visible and we need to remove it. So on false, it is already invisible, it needs to be invisible, so we leave it, don't touch it. Now here, once again, we're going to get our animation. If it is playing, so on true right here, plug this in here. If it isn't playing, it's rather simple. We're just going to say play animation reverse. So play reverse like this. Very simple, no problem here. Now on the other hand, if it is playing, we want to check if it is playing forward. So is playing forward, because it could be that it is doing this and it still hasn't finished. Now in our case, it's 0.2 seconds, so it's very fast, but we still want to check in case. So if it is playing forward, then we want to stop it and reverse it. So in that case, now we have a little issue, because right here we're going to need our current animation time, and we're going to need to stop the animation. So we're going to say stop animation here. But the issue is if we call this like this, and we then call our play animation like this, and we want to make sure this is in reverse. The problem is if we do this, this doesn't work. And the reason this doesn't work is because when we stop the animation, this automatically sets it back to 0. And so that means it will just teleport to the end, which is not what we want. So the way we resolve this issue is we need this to be saved. So normally the solution would be to promote this to a variable, pass the variable in here, save it here. But there is another alternative now with, I think, 5.6, where we can right click on the pure node and show the execution pins. And so what this does is it allows it to save essentially the variable here as a result before it passes it to here, meaning that now this variable is essentially a set and the information comes in here instead. Whereas if it was a pure node, it would only be called once this function gets called, which is already too late. So that resolves that issue. And now we should have everything working just fine. So if we go and compile and save, if we go and walk up towards this, we're going to get the small icon first. But if we get closer, we can now interact with F. And if we move back, it reappears. Move closer, it appears, disappears, appears, disappears. Quite smoothly. So that's our goal here. And if we move to the next one and get close enough, F appears as well. If we move away, same thing. And here as well. So that does it for this first part. I was initially planning on going over the actual interact button here, but due to the fact that it is already so long that I've been recording this, I think it has been about an hour, a bit over an hour, almost an hour and a half. I thought it would be a lot shorter than that. I hope you still enjoyed the video, and I hope you liked the interaction part. Especially, I think it's a bit nicer and a bit smoother than the usual stuff of just it appearing out of nowhere. And I think it works nicely with how Resident Evil does it as well. So I hope you enjoyed the video. I want to thank everybody, especially on Patreon, who's been still supporting me, even though I haven't been uploading for almost half a year now. So thank you so much for that. It means a lot. Hopefully, I'm not sure when this will be coming out, but I think all 3 parts will be coming out either at the same time or in very rapid succession. So thank you for watching, and I will see you in the next part. Goodbye.